What I will talk to you about is the research project that I have in mind, but I also take the opportunity to accept the challenge of going a bit further beyond the disciplinary boundaries of my activity and my ideas. And the title is Plants and Light from Physics. I'm not a physician, I'm a physicist. Physiology, ecology to elsewhere, because this is what we have in mind to achieve here, to go further behind that. So talking about plants and light is a very complex domain, extremely complex, and plants and light play a crucial role, a very important role in the equilibrium of our planet. And so we have to bear in mind that there are some big pictures and some small pictures. And I will try to go through that in the next few minutes. The big picture that we all see and we all talk about in these days is climate change. Climate change is due to an effect which is called the greenhouse effect, by which the atmosphere, which is filled up with greenhouse gases, is trapping more energy which is coming from the sun. So part of the energy that reaches the surface cannot go back to the space, and this warms the atmosphere. And we are here, the radiation which is absorbed by the atmosphere. And we have to do something to avoid that in the future this greenhouse effect will cause a major problem to our planet. The other area that we deal with is the reflection of light from the surface. Those are the only 2 points, this one and that one, in which humans can do something to this planet. Because we cannot change the light which is coming from the sun, we cannot change the climate, we cannot change anything, but we can reduce the greenhouse pollution, so the amount of greenhouse gases that we put in the atmosphere, but we can also change the properties of the optical properties of our planet. This is not a surprise, because we did it a lot of time already in the past by changing, going from forest to agriculture, going from desert to cultivated land. So we have changed many times the optical properties of Earth. To make a very long story a bit shorter, we are facing this problem. On the one hand, we have the greenhouse effect, which is adding 2.9 watts of energy per meter square onto the Earth on average. And on the other side, we have the possibility to manipulate and modify the amount of reflected radiation. And if we make an Earth which is lighter, we can reflect the light and we can easily reduce the energy burden which is caused by the sun. And this is called albedo, and is the alpha which is in my project. Albedo is the amount of light which is reflected from the surface back to the space. Now, on average, we are around 0.14, but if we change this 14% of light which is reflected from 14 to 15, or as I wrote here, from 20 to 22%, we can reduce very much the load of the sun on the planet. And this may have tremendous consequences. And this is a simulation made by some colleague in the UK, where they observed that if we change the surface albedo, so the amount of light which is reflected back to space, only by 0.04, so going from 0.2 to 0.24, we can easily reduce the temperature of the upper part of the planet, the northern part of the planet, by 1 degree. This is a simulation, and we have to understand. On the other hand, we have the surface. The surface is a complex, is a very complex mosaic of many different things, including the ocean, the earth, and everything. But basically, we can look at those 3 points. Here we have the light coming from the sun. This is the light of the sun after entering into the atmosphere, so the light at the surface. And you see that some of the light has been absorbed by the atmosphere. And this is what is reflected back to the sky, to the space, by the vegetation. This is a typical part, and there's a typical diagram of the vegetation. You see here is the visible part of the light spectrum, so what we can see, the colors that our eyes can see, and all of this we cannot see, but this is light or energy which is reflected back to space. And the plants are here. They reflect most of the light in the green region of the spectrum, and that's why the plants are green. That's why our planet is green.